Welcome to this video. So in this video, we are going to talk about hypothesis testing. Okay, so we're going to discuss what it is, okay, and how we can solve questions concerning hypothesis testing. So with me here, I have a tutorial sheet with questions on hypothesis testing. Okay, so I'll be explaining the concepts of hypothesis testing as I solve these questions. So in this tutorial sheet, I have 5 questions, okay, which I'm going to solve. So by the end of this video, you're expected to know everything about hypothesis testing. Okay, so these are the questions that we're going to solve. And then now let's look at the basics of hypothesis testing. So meaning the definitions and what it means to do a hypothesis testing. Okay, so the first one here is what is hypothesis testing? So that's just the definition. So by definition, you're going to say hypothesis testing is a statistical method that we use to make decisions or to draw conclusions about a population parameter. So a population parameter could be the mean, okay, it could be proportions, or it could be the variance. Okay, so these um, these are conclusions that we make, okay, about a population parameter. We are going to be using the sample data that we're going to be given. Okay, because it's easier to work with the sample, and then we generalize whatever the sample is telling us about the whole population. Okay, so we use hypothesis testing, okay, when we want to check if there's enough evidence to support or reject a certain claim that we're making. Okay, so a good example is this one that I've written here. So for example, if a company claims that the average weight of their sugar packets is 1 kg, okay, you can take a sample of these packets and actually test using hypothesis testing if the average is really 1 kg or it's not 1 kg. Okay, so as we'll be solving these questions on hypothesis testing, it's very much important, okay, that you know these definitions that I've put here. So for example, you have to know the definition of a population. Okay, so that's just the entire group that you're studying. So in this example that I gave here, it would be all the packets of sugar. Okay, and then the sample is just a smaller group that you take from the population. So from all these packets of sugar, we can just get like 30 packets. That will be the sample. Okay, and then a parameter, this will be a fixed number that describes something about the population. Okay, so e.g., the true population mean, the true population variance, okay, that one will be a parameter. And then a statistic, okay, not statistics, but a statistic will be a number that will be calculated from the sample. Okay, so for example, the sample mean indicated by X bar, that is a statistic. Okay, and then you also have to know, of course, what hypothesis is. So this hypothesis is just a statement or a claim about the what? The population parameter. So if, for example, if I get this statement here, okay, so from this statement here, I can come up with 2 hypotheses. Okay, so we have what we call as the null hypothesis and the alternative hypothesis. So the null hypothesis is indicated by H0 there. Okay, like this. H0. This means the null hypothesis. So the null hypothesis is the statement of no change, no difference, or no status what? Quo. Or status quo. Okay. So it is represented by H naught. For example, I can say, in this case here, for these packets of sugar, I can say my null hypothesis is that the population mean is equals to what? 1 kg for those packets. And then the alternative hypothesis will be the opposite of the what? Of the null hypothesis. So the alternative hypothesis, it will be a statement of change, difference, or effect. So this null hypothesis is indicated by H1. In some books, they use HA, okay? Even in some other books, I've seen HB or any other data that you can think of. So this alternative hypothesis, okay, is going to be the opposite of whatever the null hypothesis is doing. Okay, so here I'm saying the population mean is equals to 1 kg. So it means the alternative hypothesis is going to oppose the null hypothesis. So it's going to say the population mean is not actually equal to 1 kg. Okay, so this here simply means that we are testing, okay, if the population mean is equals to 1 or not. And that statement is going to be indicated by the what? The alternative hypothesis. Okay, so what we notice here is that for the null hypothesis, okay, in its statements, you should always have an equal sign. And then for the alternative hypothesis, okay, in its statement, there's no need for the equal sign. So for example, okay, if I'm testing, okay, if my population mean is greater than 1 kg, okay, so because I cannot see an equal sign in this statement here, I'm going to assign this to my alternative hypothesis. So it means the now hypothesis should be opposing this this statement here. So the alternative is saying the mean should be greater than 1 kg. So it means the null hypothesis will say that the mean should be less than or equal to 1 kg. Okay. Again, if I'm testing that um, if I'm testing that my population mean is less than 1 kg, okay, since I don't have the equal sign in here, I'm going to say this is my alternative hypothesis, and then my null hypothesis will oppose this. So meaning that my population mean should be greater than or equals to what? 1 kg. So you see that the null hypothesis always has some form of equality, because here there's a equal sign down there, even there's the equal sign down. But in the alternative hypothesis, there is no equal sign whatsoever. Okay, so these three scenarios, this one here, this one, and this one, gives us three different tests. Okay, so this one here gives us what we call as a two-tailed test. Okay, it gives us a two-tailed test. And then this one here gives us a one-tailed test. And then specifically, since the alternative was hypothesis as a greater than, it gives us the right-tailed test. Okay, right-tailed test, because the alternative hypothesis is saying greater than. And then here, since the alternative hypothesis is saying less than, then it gives us a left-tailed test. Okay, a left-tailed test like that. Okay, so these are the three tests that we are going to be encountering when you're doing hypothesis testing. Okay, it's either it's a two-tailed test, it's a one-tailed test that can either be right-tailed or it can be what? Left-tailed. Okay, so this is basically what we'll be doing, okay, when we are talking about these null hypothesis. Okay, so now I'm just going to um, I'm going to mention, okay, uh, specifically what we use the null hypothesis for. So for example, the first one there, okay, I'd said my null hypothesis is that the population mean is equals to 1 kg, right? Okay, and then my alternative was that this mean actually is not equal to 1 kg. So we said this one here is a what? Two-tailed test. Okay, and then the other one was the right-tailed test. Okay, right-tailed. Here I'd say that my H-war is that this guy, okay, so my right-tailed test, it's right-tailed because of what I have in the alternative hypothesis, okay? So the alternative said the mu should be greater than 1 kg. So meaning this guy is going to say less than or equal to 1 kg. Okay, but some people here, they will just put the equal sign. It doesn't make any difference, okay? It doesn't make any difference. Even if they just put equal to like this, and then there it is greater than, it doesn't make any difference. Okay, and then the other one, we had said it was left-tailed test. Okay, so here we had said now hypothesis is that the mu should be greater than or equal to 1 kg. Okay, and then the alternative one, which determines the name of this test, since it's left, so it means the mu here should be less than 1 kg. Okay, so in hypothesis testing, okay, the idea or the assumption is that we always assume that what we have in the null hypothesis here, okay, we always assume that this is true. So in our test, we're trying to prove or disapprove, okay, the null hypothesis. Okay, so how do we do that? We use what we call as the significant level or the confidence level. Okay, so let me write it here, significant level. So this significant level is indicated by the Greek letter alpha like this, or we can talk about the confidence level. Okay, so we can get the significant level from the confidence level. We can also get the confidence level from the significant level. So the confidence level there is indicated by CL like this. That's the confidence level. Okay, so to get the significant level from the confidence level, you just say 1 minus the confidence level, which is usually given as a percent, okay, and then divided by 100. So this is the formula that we're going to be using, okay, to find the significant level if we are given the what? The if we are given the confidence level. Okay. And then it can also be true that you are given the confidence level. Okay. I mean, you are given the significant level and then you want to find the confidence level. So in that case, we'll just make this CL the subject of the formula. So it will be CL over 100. If I take it to the other side, and then the other side I have 1 minus C alpha. Okay, and then I multiply both sides by 100, right? So to be the confidence level is equals to 100 and then 1 minus alpha like this. So if you're given the significant level there, which is also a percent, you can find the confidence level. If you're given the confidence level, you can find the significant level. Okay, so why is this significant level very important? Okay, so the significant level specifies the size of the rejection region. Okay, in short, it gives you the critical region, okay, for your test. So that critical region is going to help us, okay, to determine if we should reject the null hypothesis or we should what? Fail to reject the null hypothesis. Okay, so that's what this significant level is used for. Okay, so I'm going to draw 3 diagrams here. Okay, that will going to be helping us to identify the rejection region and the region where not to reject. Okay, so when you're given data, you will be required to calculate what we call as a statistics. Okay, so a statistics is calculated from the data. So that statistics is also called as the observed value. So if the observed value falls in the rejection region, we're going to reject the null hypothesis. If the observed value falls in the region where we're not rejecting, okay, we are failing to reject the null hypothesis, then we are going to fail to reject the null hypothesis. So the first one will be in this case where I have a two-tailed test. So if I have a two-tailed test, okay, it will be something if I draw it, it will be something like this if I draw it. I have the normal curve here that coming like this. So since this is a two-tailed test, okay, then there's some value of Z here, and there's also some value of the observed value there, such that I'll shade to the right here, and then here I'll shade to the left. Okay, so remember we said the significant level here indicates the magnitude or the size of the rejection region, right? So here the rejection region is divided into 2. You can see there's this part to the right and this part to the left, if it is a two-tailed test. Okay, so this part is going to be alpha over 2, and then even this part is going to be alpha over 2. Okay, and then here in between here, this will be our fail to reject region. So meaning if you calculate your observed value, later on we are going to know how to calculate these observed values. If you calculate your observed value and it falls within this fail to reject region, then we're going to fail to reject the null hypothesis. But if it falls there or it falls there, then we're going to reject the null hypothesis. Okay, so in formula form, this part here, in formula form, if for example I'm using the Z statistics, okay, let me say here, for example, I'm just using the Z statistics, okay, which is given by alpha bar, I mean Z bar minus population mean over the standard deviation for the sample and then root of n. So if, for example, I'm using the Z statistics here, okay, then this, if I write it in terms of a formula, okay, if I write it in terms of the formula, it's going to be, I'm going to say reject, okay, I'm going to say reject H naught if, okay, the modulus of Z is greater than the Z observed value. Oh, this is the observed value now. If the modulus of the observed value, maybe I should write it like this. I should write Z observed like this. Okay, so Z observed. If this Z observed is greater than the Z value from the table. Okay, so Z value, I just write Z squared value from table. But we're going to later on find out how to find it. So this Z value from the table is going to be based on this alpha over 2. So in short, sometimes we write it as Z alpha over 2. Okay, so if your observed value that you calculate is greater than, the modulus of the observed value that you calculate is greater than Z alpha over 2, then we're going to reject the null hypothesis. Okay, if it's not, then we're going to fail to reject. Okay, what about the right-tailed test? So the right-tailed test, we have just one rejection region because it's right-tailed. So here the same mean is greater than. So meaning the rejection region will just be on one side like this. So this one side will be indicated by the alpha there. Okay, so here we're going to reject H naught okay, if the Z observed without the modulus, okay, the Z observed without the modulus. Here we're putting the modulus because the two-tailed. So Z observed is greater than the Z alpha. So you're just going to be alpha because it's not two-tailed, it's just one-tailed like this. Here it was alpha over 2, no wonder I put alpha over 2. Okay, and then the other region that remains here, all the way from here up to there, is our fail to reject region, meaning that if the Z observed is actually less than this, we're going to fail to reject the null hypothesis. Okay, and then the other one is when we have the left tail test. So this one is going to be like this. So since it's left tailed, then the rejection region is on the left like this. So this guy here is going to be our alpha. So here we're going to reject H naught if the Z observed, okay, is less than the negative of the Z alpha like this. Okay, then we're going to reject. If this guy is greater than this, then we are going to fail. Okay, we're going to fail to reject. Okay, we're going to fail to reject. Okay, so that's what we're going to be doing as we're doing this hypothesis testing. And then here, you're going to be fail to reject. Okay, so that's what we have there. Okay, so when you're doing any hypothesis testing questions, okay, there are always steps that you have to follow. So I've written down the steps here of whatever I was explaining there. Okay, so the first thing is to identify the testing problem, and then you state the null hypothesis and the what? The alternative hypothesis. After you state your null hypothesis and alternative hypothesis, okay, you determine the test statistics that you're going to use. So this test statistics is going to be based on the information that you've been given in your sample data. Okay, so I'm going to be explaining why we'll be choosing certain test statistics as we solve the questions. Okay, so depending now on the test statistic that you have, okay, whether it's a T, it's a Z, it's F, or it's a chi, okay, you're going to determine the critical region. So in this critical region, okay, the critical region is simply the rejection region. These things that we are finding here, this guy here, this guy there, this guy, and this guy, these are what we call as the critical region or the rejection region, okay? So we're going to determine clearly the critical region or the rejection region. And then you also clearly indicate whether the test that you are doing is a one-sided or a two-sided. So a two-sided is what we are calling a two-tailed test. This is a two-sided. And then if it's one-sided, it can either be right or what? Left-tailed. So that's what you do on point number 3. Okay, and then from there, you're going to use your statistic that you had here, okay, to calculate the observed value of the test statistics. Okay, and then once you have that value, you are going to determine it if it falls in the critical region or it falls in the fail to reject region. Okay, and then based on that, you make your conclusions. Either you're going to reject the null hypothesis or you are actually going to fail to reject the null hypothesis. Okay, so that's what we're going to be doing. So now let's look at this question here. So this is question 1 from the tutorial sheet. Okay, so I'm going to be explaining why we are picking certain statistics as we solve the questions. So here, we're saying a random sample, x1, x2, all the way up to x10. So simply meaning here that our sample size is what? 10. Okay, from a normal distribution. So meaning x there, I follows the normal distribution. Okay, follows the normal distribution like that. Okay, as the summation of all the x's that are there are giving me 120.19. And then the summation of all the xi squared is giving me 1693.6361. Okay, so the first question here, it's a very simple question. They're saying calculate the mean and the variance of the sample. Okay, so that one you know. Okay, how do we calculate the mean and the variance of the sample? So I'm going to say part 1, the mean is x bar is equals to, okay, that's equals to the summation of all the xi divided by what? N. So the summation of all the xi is 120.19 divided by n, which is 10. So here gives me my x bar to be 12.019. Okay, so this will be my mean. And then my variance of the sample indicated by s squared will be equals to, the formula for the sample variance is 1 over n minus 1. And then inside the brackets, you're going to have the summation of all the xi squared minus the summation of all the xi and then you square it, and then you divide it by what? 10, like this. So let's just put in the numbers there. So it will be 1 over n minus 1. N is 10, so that will be 10 minus 1. That will give me 9. And then inside the brackets, the summation of all the xi squared, it's 1693.6331 minus. And then here inside the brackets, we have the summation of all the xi, and then we square it. So we're talking about 120.19, like this, and then we square it, divided by n, which is 10, like this. Okay, so the only thing that is left now is to punch this guy onto the calculator. Okay, so let me do that. So if I punch these guys onto the calculator, I'm getting 27.6744. So I've just rounded off to 4 decimal places. So make sure you counter check with your own calculator if you're able to find the 27.6744. Okay, so meaning that my X bar, which is the sample mean, I've found it is 12.019. And then S squared, which is the variance of the sample, is 27.6744. Okay, so we can also find the sample standard deviation. So the standard deviation, S, will just be the square root of this variance here. Okay, so counter check again with your calculators. Mine says 5.2606. So right here, standard deviation is just 5.2606. Okay, so that's what I have, the data. Okay, so I've calculated sample mean, sample variance, sample standard deviation. I've answered part 1. Part 2, tests at 5% level of significance. Okay, so meaning that my alpha there is just 5%. So 5% is the same as 5 over 100, which is 0.05. Okay, so test at 5% level of significance whether the mean of a population is 15 if the population variance is unknown. Okay, so we said in any hypothesis testing question, we are always going to follow these things here. Okay, so the first thing is to state the null hypothesis and the what? The alternative hypothesis. So let's do that. So here I'm going to say step 1. Now hypothesis there, and then alternative hypothesis there. So here the tests, they are saying we test whether the mean is 15. So meaning that the population mean is equals to 15. And then this alternative is just going to oppose this statement. So meaning that the mean is actually not equal to what? To 15. So this is part 1. Okay. Part 2. According to this, they said we have to identify the test statistic. So the test statistics, you identify it based on the information that we've been given. So for this sample here, remember our n was just 10. And then here they're saying the population variance is unknown. So the population variance is indicated by sigma squared like this. So this is unknown. Okay, so if the sample size is 10, meaning that 10 is less than 30, right? So if the sample size is less than 30, and then the population variance is unknown, then the test statistic that we're going to use there is just going to be T is equals to, we're going to use the T distribution, okay? Sample mean minus the population mean, okay? And then um, divided by the sample standard deviation over root of n. So how do I know which statistic to pick here? So there are rules that we have to follow. So I've put them here. Okay, so here I'm saying test concerning our population means based on the sampling distribution x bar or the difference of two sample means like x1 bar minus x2 bar. Okay, assuming that the hypothesis, assuming that the null hypothesis is true. Okay, so we use the following statistics here. So I've written them down. So I have 2 of them. Okay, I have 4 situations that I've just categorized them into 2. So if X follows a normal distribution, like the way our question did here, they said normal population. Okay, we use the Z statistics. Okay, this guy here. We use the Z statistics if the population variance is known. Okay, so if the population variance is known, then we're just going to use Z is equals to X bar minus mu not, okay, meaning the mu in the mu in the null hypothesis, okay, divided by the standard deviation of the population gotten from the variance of the population because it's known, then divided by the root of n. Okay, that is when x follows the normal distribution and the population variance is known. Okay, we use this. And then if x follows the normal distribution, like we had here, it followed the normal distribution, and then the n is less than 30. Okay, so in that case, our n was 10, which is less than 30. And then the population variance is unknown. Then we have to use the t statistics, which is this one here. Okay, so it's the one that I wrote there. So that's what we're going to use. And then there are other cases. Okay, cases you can have that your x has a mean mu, okay, and a variance sigma squared. So meaning here that the variance is known. Okay, the variance you have it, the mean you have it, and the sample has a size which is greater than 30. So meaning the sample size maybe is 31, 40, okay, whatever number is greater than 30. So if the variance is known, then you are going to use these statistics here, same as this one here, okay? And then if the variance is unknown, okay? So pay attention here. They're saying if the variance is unknown here, then our Z statistics changes, okay? So whatever I have on top here is the same, but here notice where I add the standard deviation for the population, sigma like this, I now have the sample standard deviation and then over the root of n. Okay, so we are using the estimate here for the sample because the variance for the population is what? Unknown. Okay, so if the n is greater than 30, then we use this. Okay, but if the n is smaller than 30, then we use the t distribution. Okay, so on all these others, we're using z, 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 but here we use the t distribution. So that's what we are going to do here. So no wonder I picked here. Okay, I picked this one. And then let's calculate it. Okay, let's calculate the t value. So the second thing is just to calculate this t value. So t value will be equals to x bar, which is 12.019. And then the population mean, I should take a note here, to just be this 15. So 15 over the standard deviation for the sample is 5.2606 divided by the root of what? 10. So we punch this onto the calculator and see what we get. So my calculator says I get minus 1.79194. So that is the value, okay, of the t statistics, or in short, that is the value of my observed statistics. So I'm going to write t is equals to minus 1.79194. Okay, so we are done with step 2, where we identify the test statistics here. The third step, according to this, so I'm referring to this so that it gets to your head. Okay, so we are now going to identify the critical region. So the critical region depends on whether it's a one-sided test or it's a two-sided test. So two-sided test, this one, because in the alternative hypothesis I have that mu is not equal to 15. So it means it can be below 15 or it can be above 15. Okay, so it means 3. My critical region will be remember that table, that diagram that we drew here, because it's a two-tailed test or two-sided test. Okay, I'm going to have a rejection region there and a rejection region there. So this will be my first rejection region, my second rejection region. So this one here will just be alpha over 2. Even this guy will just be what? Alpha over 2. And then this region on the middle is going to be our fail to reject region. Okay, and then we said this guy, if we write it in terms of the formula, okay, so if I can go back here, if we wrote this in terms of the formula, and then here I was using the Z statistics. So I said the modulus of the Z observed calculated from this guy, okay, if it's greater than the Z alpha over 2, then you're going to reject H naught. So now here, I'm using the T. Here, I'm using the T, okay? So if I write it in terms of the formula, which is what you should know, okay? It's going to be, I reject H naught if the modulus of T, okay, is greater than the T value from the table. So this T value from the table is going to have this alpha over 2, okay, and then comma, n minus 1. So this n minus 1 is just the degrees of freedom, okay? It's just the degrees of freedom. Now remember, my alpha was 0.5, right? 0.05, I mean. So meaning that my alpha over 2 is going to be 0.05 divided by 2, which gives me 0.025 like this. Okay, so meaning, let's find this. So it will be t. This alpha over 2, it's 0.025, comma, n minus 1. N is 10. So meaning this will just be 9. Okay, so let's find this value and see if it is less than modulus of t. Okay, so I'll go to my, where am I now? Okay, I'll go to my t distribution table. So the t distribution table is here. So I'm looking for t 0.025, comma 9. So meaning the degrees of freedom are 9. And then for the one tail test there on top, I'm looking for 0.25 because I'm just considering one side here. So it becomes like a one tailed when I'm going to the t distribution. If you want to use the alpha value for the two-tailed test, then you have to use this one here. But here I divided it into two, like that. Okay, so we are looking for this value here, t of 0.025 and then comma 9. So I'll just go to this table here. Where's the table? Okay, so it's here. So on this table here, I'm looking for t 0.025, comma 9. So the 0.025 is there. You can see it there. Okay, and then degrees of freedom are 9. So from here, I'll go to the left, to the right like this. And then from here, I'll come down like this. So I end up at this value, which is 2.262. So I'll come here and write 2.262. So now I compare, okay? If I get the modulus of this, okay, it will be the modulus of minus 1.79194. So this will just give me 1.79194. So we see that this number here, the modulus of this is actually less than the 2.262. Okay, so we said we are only going to reject the null hypothesis if the modulus of this is greater than this. But here we find a contradicting statement because this guy is actually less than this. Okay, so our conclusion there will be that we fail to reject. Okay, so I'm going to say fail to reject. So this would be 4. Okay, so part 3 was writing this rejection region. This was number 3. And then part 4, now I'm going to write it here, okay? Which will just be the conclusion based on whatever we've done there. So I'm going to say we fail to reject H naught. Okay, why do we fail to reject H naught? Because the modulus of the observed value is less than the t, the t at 0.025 level of significance and then comma 9 degrees of freedom. Okay, so we fail to reject H naught. Okay, so what does that mean now in our conclusion? So in our conclusion, we're going to say at 5% level of significance, okay, we do not have enough evidence to say that the population mean differs from 15. Okay, simply saying that the population mean that we had, I mean, the sample mean that we had found that it was 12.019, okay, simply saying that this value is not sufficiently far from 15 when counting for sample variability and small sample what sizes. Okay, so that will be the answer to part 1, part 2, I mean, okay. So as usual, you can see the steps here. State the null hypothesis, determine the t statistics based on the information that you've been given in that question. And then once you calculate it, come up with the rejection region, which we did here. We said reject H naught when the modulus of this is greater than t alpha over 2 and then n minus c 1. So we are picking alpha over 2 here because this is a two-tailed test. Okay, and then 4, we make a conclusion based on whatever we're going to find. So we said we failed to reject H naught, and then 5, we make it a huge statement concerning our 4. So we said at 5% level of significance, we do not have enough evidence to say that the population mean differs from 15. Okay, so that was part 2. So now let's look at part 3. Okay, so recall what we had found. We had found that the sample mean is 12.01, okay, 019. And then the standard deviation is, okay, recall that we had found it was what? It was just the square root of the variance, which we found was 5.2606. The variance itself we had found was 27.6744. Okay, so this is what we had found. So from here now, we can go to part 2. So part 2, okay, they're saying at 5% level of significance, which means our alpha is still 0.05, okay? Tests, okay, whether the mean of the population is 15 if the population variance is 20. Okay, so here, first thing, state the null and the alternative hypothesis. So null hypothesis be that the population mean is equals to 15. The alternative hypothesis would be that the population mean is not equal to 15. Okay, and then now we come up with the test statistics, right? So here, the sample, okay, the sample size is still 10. Okay, but the variance, okay, the population variance is known as 20. So if from here we can find the population standard deviation, which will just be the root of 20. So it doesn't matter, okay, what size of the sample you have, as long as, okay, as long as the population variance is known, then we can use the Z statistic. So here, the statistic that we're going to use, we're just going to use the Z statistic. So we're going to say Z is equals to sample mean minus, okay, the mu naught, meaning the mean of the null hypothesis divided by, since here the sample, I mean the population variance is known, we can find its um, standard deviation. So it's going to be sigma over root of n. So this is the statistics that we're going to use. So we're going to say 12.019 minus 15 over root of 20 divided by root of 10. Okay, so we just punch this into the calculator. Make sure you counter check. My calculator is saying minus 2.1097. Minus 2.10788853. That's what my calculator is saying. Okay, so that is my Z observed value. So I can write it here too. The Z statistics, okay, the Z observed value is equals to minus 2.107885 what? 3. Okay, so what was the step 3? Step 3 here saying define the critical region. Okay, so the critical region you first identify, is this a one-tailed test or is it a two-tailed test? Okay, so we see that we have in the alternative hypothesis, we have that this population mean should not be equal to this. So this is two-tailed because this means that the mean can be above 15 or it can be less than what? 15. Okay, so it's a two-tailed test. So if I draw it, it's going to be like this. Okay, it's going to be having two rejection regions. This one here, maybe I should draw it properly. Okay, that's too much. So should be like this. So there will be that region and this region because it's two-tailed. Okay, so we have two rejection regions. We have this one here, and then we also have this one here. Okay, so it means this alpha we are dividing it into two. So here I have alpha over 2, here I have alpha over 2. Okay, and then this region in between is our fail to reject region. So we're going to reject if it's here or if it's there. And then in terms of the formula here, we had said, okay, we reject H naught if the modulus, okay, of the Z observed value, okay, is greater than the Z alpha over 2. Okay, so to find the Z alpha over 2, I'm going to show you a very simple method where we use the confidence level. Okay, so remember I said you can actually find the confidence level when you've been given the what? When you've been given the significant depth. Okay, so the confidence level is just equals to 100 and then 1 minus the alpha there. So this would just be 100, 1 minus 0.05, and then to be 100. So inside there, what am I going to do? What I'm going to get? To be 1 minus 0.05. So that would be 0.95. Okay, so the confidence level is 95%. Okay, it's 95%. So the Z value, okay, or the Z curve value that you get at 95% is equals to 1.96. Okay, so how do I get this value? There's a table that you have to know. So this is the table here. Okay, this is the table that you have to know here. So if the confidence level is 90%, the Z-score value is this. If it's 95, the Z-score value is this. If it's 99, the Z-score value is this. 99.5 is this. 99.9 is this. So for you guys, I'm sure you really have to know the 95% one and the 90% and maybe the 99. Okay, so make sure you know these three. So you just see a 95% confidence level, then it's 1.9 6. Okay, so but you can actually calculate it using this confidence level. So using the confidence level, if you want to get the Z-score value there, 9.96, you can do this. So you can say, let me calculate the area to the left, which will just be 1 plus the confidence level divided by what? 2. So this will give me, okay, so that's the formula that you can use on how to calculate those values that I was showing you, these values here. Okay, you can use this formula here. You can just say area to the left, 1 plus um, uh, area to the left, and then 1 plus confidence uh, level, which is 95, and then divided by 2. So this confidence level, you are going to express it at a decimal. Okay, so if I have 95, this decimal is 0.95, right? So it will just be 1 plus 0.95 divided by 2, and then I'm going to get okay, I'm going to get what? I'm going to get 0.975. So I say this is the area to the left on that Z-score table. Okay, so when you go to the Z-score table and find the area 0.95, okay, it's going to give you this 9.6. So let's see if it actually gives us. So the normal distribution table is somewhere here. So this is the negative one. So let's go to the positive one. Okay, so the area that I found there was area to the left, I'd found it was 0.975. So I'm looking for these probabilities on these probabilities here. So 0.975, 0.975, where are you? 0.9757273. Okay, so 75 is there. You've seen the 75 here. Okay, so 0.75 is here. So if I go up and I go to the left, I find 1.9, 0.06. So 1.9, if I add 0.06, I get my 1.96. So that's how I find this value here. Okay, so it means this Z alpha over half is just going to be 1.96. So I'm comparing now this Z observed to this value. Okay, what do I get? Okay, so this was our step what? Identifying the rejection region was part 3. Okay, so this is part 2, then this is part 3. So let me just write it in terms of like a simple statement. Okay, but I had to write all that for you to understand. So 3, we said reject H naught if the modulus of the Z observed is greater than the Z alpha over 2. Okay, but the Z alpha over 2, we have found it's 1.96. Okay, so that's what we have found, that it's 1.96. And then the Z observed is this one. So, well, let's make a decision now here. So we see that if I get the modulus of this guy here, I'm just going to find 2.1078853, which is greater than this value, the Z alpha over 2, which is 1.96. Okay, so if it's greater, then our decision here will be reject H naught. Okay, we're going to reject H naught, and then 5, we make the conclusions now. Okay, we're going to make the conclusions on 5. So here on number 5, we are going to say at 5% level of significance, okay, with the assumption, okay, that the population variance is known to be 20, okay, the data shows a significance evidence, okay, that the mean differs from 15. Okay, so we are rejecting this statement here that the mean is equals to 15. We are rejecting it, okay? So meaning that we are supporting the what? The alternative hypothesis. Okay, so we're going to say at 5% level of significance, the population mean differs significantly, okay, from what? 15. In fact, the sample mean is significantly less than what? 15. Okay, so that would be the conclusion here. We're going to say at 5% level, okay, of significance, that should be S. 5% level of significance, okay. The population mean differs from 15. That's what we're going to see there. Okay, so that is it about question 1A. And then we move now to question 2B. I mean, question 1B. Okay, so question 1B, where are you? So it's here. So question 1B, okay, we are doing the hypothesis testing based on two means, okay, based on two population means. The one that we did on A, we just had one mean. Okay, so for two population mean, we're going to see that the formulas of those statistics that we're going to be using, they're also going to differ. Okay, but how to find the rejection region, the failed to reject region is going to be the same. So before I solve this question, okay, let's look at this. Okay, so if I have two population means, what does how do we handle it? Okay, so two population mean where it's in this table here. Okay, so this is all that you have to know about two population means. Right, so thank you so much for watching this video. If you would love to access the full video solutions to all the questions that you can see in this tutorial sheet, okay, you are welcome to register with our institute, okay, and you can access the full videos on our website. We've solved all these questions here, as well as all the questions from the tutorial sheets and the assignments and your tests. Okay, so when you happen to go on our website looks something like this. So when you log in, you create an account, okay, you will see something like this. And then on the course that you've enrolled in, you see enrolled there on top. So you can open this course because that is math. So you open the course and then you come to this folder, General Mathematics. So you open General Mathematics, okay? And then you go to the folder for the tutorial sheets and the assignments. If you want past papers, tests, quizzes, exams, you come here. But we go to the tutorial sheets. So I open the tutorial sheets. You're going to find your university. So if you are from Unilus, you find Unilus. If you're from Apex, you find Apex. If you're from UNZA, you find UNZA. So that tutorial sheet is from Unilus. So I just open Unilus here. Okay. If I open Unilus, I'll find semester 1 and 2. So that was for semester 2. So you can go in semester 2 here. Okay. And then you go to the video solutions. So the video solutions, you're going to find that you find the assignment 1. There are full videos there. Tutorial sheet 1, which was on trigonometry, we have full videos. Tutorial sheet 2, all the questions have been solved. Tutorial sheet 3, 4, 5, 6, all the way up to tutorial sheet 7, which is on hypothesis testing. So that tutorial sheet had 5 questions. So if I open it, okay, you see that I have exactly 5 questions here. So 1, 2, 3, 4, I've separated them according to the question number. So you can watch this at your own pace, at your own time, and get to understand how to do these things on hypothesis testing. Okay, as well as you can also watch the videos on all the other tutorial sheets. Okay, so it's a very good platform if you want to learn on your own, at your own pace. Okay, it's a very good platform. Okay, so it's just loading there. Okay, so it's done. So you can see even tutorial sheet 5, normal distribution, we solved all the questions. Tutorial sheet 6, we solved. So you can actually be using these videos as you prepare for your exams. Okay, you can actually be using these videos as you prepare for the exams. Okay, and then if you are from semester 1, we also have videos for the tutorial sheet for semester 1. You go in the folder for semester 1, and then you go to the video solutions, and then you go to the July intake, this one here. So you open the 2025 July intake, you're going to find the video solutions for all the tutorial sheets. You can see from assignments, tutorial sheet 1, all the way up to tutorial sheet 7. So you can use these videos to learn at your own pace. Okay, so thank you so much and feel free to register with us.